All right, no thanks to you guys. Nobody reminded me to start the recording, but I remembered. Crazy talk. I doubt many of you will go into education, but if you did, it is shocking how many requests you are thinking about. Music ed. How many requests you get when you teach 120 people, and it's like your brain just fills up. It's like, no mas, no mas. It's like, send me an email, remind me, do something, but you just learn to kind of adapt. All right, so I am jumping to where we were. This is not where we were. And that is in your book, page, was it 75? Okay, so one of the things, we didn't even get to this second one, I don't think. I think the only thing I mentioned about it, I think I started to mention, what would it mean? Well, I think we'll just run through it and I'll remind you. So in a problem like this, what does it mean when, what does it mean? So annoying. Oh, well, I get it. Hey, guys, what does it mean when you have two factors that are exactly the same in the numerator and the denominator? It means there is a whole, and the whole can be found by doing what? So the x value would be -2, but it's a whole, it's a point, right? So you can't just stop and say x is -2. Where the heck would I plot that, right? So I got to take that -2. Second I get it, I can throw these out and never look at them again, which is going to be really helpful in a moment because I'm going to have to find a slant asymptote on this. And the only way to find a slant asymptote is to multiply it out. And it would be a real pain to have to multiply out 4 factors. It's going to be pain enough to multiply out 3. But anyway, so what do I do with that -2 to find the whole? Plug it back in. So that would give me a -3 squared, which would be a 9, times a -6 over a -5 squared, which would be a 25. So my whole ends up being -2, comma, -54/25. So in terms of sketching that whole, where are you going? About 2 and a little bit, right? So I'm going to go -2 left, and I'm going to go down 2 and a little bit and just mark a hole. And anywhere in that vicinity is good enough. All right, are there any vertical asymptotes? Yes. Yes, that's anything left in the denominator after you've canceled out the whole. Set that equal to 0, but that is the way you would leave it, right? X equals 3. Now, what did we say yesterday, very end of class? What does it mean when you see a factor that indicates a vertical asymptote, but it's squared? And it's a volcano. It's a volcano. So if it's squared there, that means that it's either going to volcano, or I guess you could call it like a drain or whatever. But either I just say volcano up or volcano down, which is good to know because a lot of times when I'm sketching it, I'm like, wait a minute, which side is that? Which way is it going? But I can look at the actual place where the vertical asymptote came from, and I'll go, oh, if it's squared, they must both be going up. The problem we did before was not squared, right? And you saw it doing this or this. I forget which one it is. But this tells me there's a vertical asymptote at 3. So I can come in here and mark that vertical asymptote at 3. But it does definitely tell me it's going to go up both sides or down both sides. All right, does this have a horizontal or a slant? And how do you know? It's a slant. How do you know that? So, yeah, and that's the only time. If the power on the top is higher, now is it guaranteed to be a slant if the power is higher? No, but if we're graphing them, it's going to be a slant. I'm not going to make you sketch a quadratic one or some other oblique one. But it has to do with the power, right? What would the power of the x's be in the bottom? X to the second. What would the powers be on the top? X cubed. So when it's 1 power higher, you'll see that in a second. When you divide, x goes in there 1 time. And an equation that has just a single x is linear, right? So in this case, yes, I can tell it's going to be a slant, which means there's no horizontal because there's only one or the other. Now, how do we find that? We're just going to have to suck it up and multiply this out. So I'm going to save you the trouble of that and just do it. So the x minus 1 squared gives me x squared minus 2x plus 1. Then I'm going to multiply the x minus 4n, which gives me which gives me x cubed minus 6x squared plus 9x minus 4, if I've done that correct. So the top part ends up being x to the third minus 6x squared plus 9x minus 4. The bottom part's a little more doable, right? X squared minus 6x plus 9. I can pretty much tell you right now on a test, I'm not going to make you do that, because if you make one little error with that, your slant asymptote looks wrong. And then when you go to plot your slant asymptote, if it's wrong, then everything else doesn't make sense because it doesn't go with it right. And it just creates a disaster. And it snowballs into too many other errors. So if I were to give you something like this, I would have probably given you the original part and this. Anyway, so how do I find that slant now? I'd love to do synthetic division, but it's a quadratic. So I'm going to have to do long division. But the upside, I know in our heads, we think long division is so bad. But when you only have to get to the constant, and you can see right now that it's only 1 power higher, it ends up being a very quick process. Look, x squared times what gives me x cubed? Just x. When I multiply it, wait a minute.
You just want those signs like a lot completely.
Did that really do that? No, it would be not. That'd be it. Let me make sure that I don't have a memory of this. Hold on. X minus 4, x minus 1 squared, x squared minus 2x squared, positive x, negative 4x squared, positive 8, negative 4. Okay. Change my signs. I get a big 0. How many times does x squared go into negative 4? None. Right? As soon as the power of x here is smaller than there, I'm done. So my slant asymptote is just y equal x. So I knew it was linear, but I didn't know it was the most, or slanted, but the most basic slant ever. This thing actually, and again, it's okay for a point or a non-point to be on an asymptote, but that's not actually on it, because remember, it's actually negative 2 point something. Right, x-intercepts, where did we say we found x-intercepts? Places where, yeah, you plug in a 0 for y, but once you cross multiply, you end up only looking at what? Numerator factors. So I look at the numerators factors for the x-intercepts, and I set those equal to 0. So x equals 1 and x equals 4. But what's special about this 1 when it's squared? It's a double root. And if it's a double root, it's going to bounce, right? So I know that 1 and 4 are roots. I can go ahead and mark 1 and mark 4, but I know that it's going to bounce off that 1. And that's a big deal when it comes to sketching. And then how do I find a y-intercept? Plug in 0 for x's. And by the way, it's better to write x-intercepts like this as points because they actually are points. When I write them like x equals 1, x equals 4, they really look like vertical lines, don't they? So if you wanted to say the x-intercepts are and list them like are 1 and 4, I guess that's okay. And honestly, I don't think I'm going to count off for that, but this is what you really ought to have, is that is the set of intercepts. That's a better way to write that. But anyway, I come over here, I mark 1 and 4. Y-intercepts are when x are 0, right?
You just do that in the actual fraction.
So yeah, if I plug a 0 in there and a 0 in there and a 0 in there, I get a negative 1 squared, which is 1, times a negative 4 is negative 4, comes over a negative 3 squared, which is 9. So you get that negative 4 ninths. Right? Now, if you could also come over here And you would have to assume that you had done all your math right, but plugging in here a 0 for x is really nice, and you get -4/9. But I don't know that I would encourage that, because if you happen to multiply wrongly, now you just missed 2 problems instead of 1, right? So I would always go back to that original thing. And 0, -4/9 is about halfway down. I'm just going to put something about right there. All right, now the last thing, and I ask this a lot, plot at least one point on either side to get a better idea of what the graph is doing. Now I can tell you right now, look, there, I'm going to do this in lavender. Like I can see, I know that I have to follow what as I head this way? The slant. I got to follow the slant. So if I know that, I'm going to go, all right, I'm coming in on a slant, right? As I get closer, I've got to go through that hole. Am I on the slant? No, but I'm just trying to give you an idea. It's probably either above or below, right? And I'm going to go through that right there, that hole. I'm going to hit that point and go through it. I got to bounce off that. And when I bounce, I'm staying below, aren't I? Is there any way I can turn around and come back up and follow the asymptote up? Why not? Because there's not another x-intercept to do, right? Is there any way I can just go and hit the brakes right there? No, because vertical asymptotes don't behave that way. Holes do, where you can just hit one side and out the other. Jumps do, which we're going to be covering in this class, where you go into a hole and then all of a sudden appear somewhere else. That's like a piecewise function. But anyway, the only thing you can do is follow it up or follow it down, and I can't follow it up. Again, back to that multiple choice stuff. Sometimes you don't know what to do, but you know what you can't do, and by default, you have no other choice, right? So I'm going to be following this down. Now in this next part, I get a lot of confirmation that I'm right, because again, I have to follow this slant out to infinity. But as I'm coming closer, what do I have to do right there? What has to happen? I've either got to follow it up or follow it down. Not only is it a volcano, which means I would have to go down, but also there's a point I have to go through. Okay, so not only do I have to come in here and go through that point, but also I've got to make it all the way down. All right, and that, I don't know what that is so much. So, tell you what, just not going to do it. I give up. So anyway, I'll put it back in there. What I had something like this. Now, what I ask you to do on your test a lot of times, especially when it's not so obvious what the graph looks like, is I'll give you a little table. And this question asked it down there, plot an extra point or two. So maybe we want to know the fact that the hole is almost on that makes me think, you know what, I'm already really near the asymptote. Maybe I check -1, maybe I check -5. I'm just going to ask you about -5. And then maybe over here, maybe I check +6. I'll give you a little table like this and say, just mark those, figure out those points and then mark them. Plugging a -5 in here gives me -6 squared, which is a 36. A -5 in there gives me a -9. And a -5 in there gives me a -8 squared, which is a 64. I can divide a 4 out of that and a 4 out of that, and I get -81/16. What is -81/16? Pretty close to -5. So I'm at -5, a little bit more than -5. And look, -5, a little bit more, a little bit lower than -5. So that makes perfectly good sense that this curve would bounce there, hit this hole, get closer and closer and closer, and it is really close at that point, and just follow this out. And then I really have no choice but to go down. And then when I plug a 6 in there, when I plug a 6 in, what was that? That's right. A 6 in there gives me 5 squared, which is 25. 6 minus 4 is 2. 3 squared is 9. I get a 50 over a 9. And what is 59ths really close to? Maybe 5-ish. So at 6, I'm up 1, 2, 3, 4, 5-ish. And look, I mean, just my guess was really close. So again, that's the idea. Follow this out, follow that down. Is there a chance that this curve right here actually crossed the slant and then followed it in from the top? It's possible. You can cross slants. You can cross horizontals. You just can't cross verticals. All right. And then right here, sometimes I give you an equation and I mean a graph and ask you to find the equation. At first glance, people go, how on earth am I supposed to do that? But then at second glance, it's not as bad as you think. In fact, I think it's easier to find the equation, and I think you will too if you know your rules. So let's just go through the rules and see if we can turn this back into something. So I'm going to go y equals, I see all these horizontals and slants, or horizontals and verticals, so I'm pretty sure it's a rational function. Is there something you can take from this graph and put it into your function right now? So there's a whole where. At -2, probably 1, but the only thing that matters is the -2. So what would the factors have been that gave me a -2? So let's just go ahead and put the hole in there. There's your x plus 2 on the top and on the bottom. And that is definitely a hole. And I am going to label that as that's what gave me the hole. And be careful, sometimes there's 2 holes in there. All right, what else? What other factors? You had factors in the numerator, factors in the denominator. Okay, roots. The roots are what? Looks like -4 right here. Also looks like -1. And roots come from factors where? In the numerator. So I know that there's a what and a what in the numerator. An x plus 4 and an x plus 1. If you don't know your rules, you're not going to get those two. But if you do know your rules, great. Did they happen to bounce at those roots? Then nothing squared. And by the way, you wouldn't know if it was a squared or if it was a 4th power. You wouldn't know unless you started considering what kind of slant or horizontal you have. But at this point, they're definitely not bouncing.
We did 2 vertical asymptotes together.
Okay, so you had 2 vertical asymptotes. Those came from what? Factors in the denominator, right? So I've got an x, looks like a x equals -3. What would an x equal -3 have come from? An x plus 3 down there? What would an x equal 2 have come from? An x minus 2. Is there any volcano action going on those? And be careful. Sometimes, I know you think volcano is really close, but sometimes, like, let's just say you had this right here. Sometimes you'll see one side really close and the other side will just barely be showing, right? And it's easy to go, oh, no, it's not a volcano. But if you kind of step back a bit, oh, wait a minute, that is eventually going to be a volcano. So be careful. And I'll show you one of those. But like, you can clearly see that one's a volcano and this one's not, this one's not, and this one's not. So nothing squared there. So right now I've considered my roots. I've considered my VAs. I've considered my hole. What's really the one thing that I haven't considered? A horizontal asymptote. Now, the fact that it has a horizontal and the horizontal is y equals 2, how do I get a horizontal asymptote that has a number that's not 0? Coefficients are the same, right? And if you look up here, x would have given you x cubed. X would have given you x cubed. Now, where it stands right now, this looks like if I had multiplied it out, I would have had x cubed something over x cubed something. That would have given me a horizontal asymptote of what? Y equals 1. My horizontal asymptote is supposed to be y equals 2. So how do I fix it? Done. And if I just throw a 2 up there, now when I multiply it out, I get x cubed times 2, right? And that would have given me a horizontal of 2. And the last thing we haven't talked about of all the things were the y-intercept. Well, the beautiful thing about this is the y-intercept takes care of itself. If you get everything in there, check it out. If I plug a 0 in for every x, I get 2 times 4 times 1, which is 16. Over 2 times 3 times -2, which is -12, and I get -4/3, right? Bam, -4/3. So you don't even have to worry about it. I guess if you wanted to check to see if you had set it up right, maybe that's worth a check, but I rarely even do that. And that is your rational function. All right, what about this one? This one's a little trickier, a little bit more going on. So, but definitely a rational function because I see vertical asymptotes and slants and holes. What do you want to do first? Sorry?
No.
The whole? So the whole is located at 2, -1. So what would the -1 part doesn't matter, the y value. The x value would lead you to what factor? So x minus 2, x minus 2. And by the way, I didn't finish doing this. This represented the whole. That number out front took care of the horizontal asymptote, right? These two numbers came from what? Roots. And those two numbers came VAs, right? And it's always that way. So right here, once again, this is your whole. And you might have more than one, so take a good look. What else you got? Okay, your roots. Looks like it hits the x-axis here at -3 and at +1 and at +4. So where would those go? In the numerator, right? So the first one for the -3 would be x plus 3. The factor for +1 would be x minus 1 squared. Why? Because it's bouncing off of that. That's the kind of thing when you forget that squared, dot, dot, dot. All right. And then right here at 4, what is that? X minus 4. So you've already put a lot of powers up there. There better be a lot of stuff on the bottom, or I'm going to get some weird outcomes. So when I look at the denominator, what and all of this, these are all coming from your roots, right? Now, else goes in the denominator other than a matching whole? VAs, right? Factors dating VAs. My VAs are at -4, so that VA would be x plus 4. I also have a VA at +3, so x equals 3, so that would have been an x minus 3. Y'all with me? So right here, what did I do? What have I left out? The x minus 3 has to be squared. Now, if I forgot that on a test, why should there be a red flag for me right now? Okay, did you hear what they said? They said the power on the bottom was x cubed. If I multiply it out, the power on the top is x to the 5th. If I were to divide an x cubed into an x to the 5th, that's an x squared. I would have a parabolic asymptote, but I don't. So the fact that I have a slant means that it should only be 1 power higher. So right there, that should be cause to go, well, what's squared? Oh, volcano on the 3. Go in there and square that. Now, when you look at it, that x-5th, x to the 5th on the top and the x to the 4th on the bottom, which is what I would have had, makes more sense. Now, am I right now? Well, let's think about it. The bottom is something x to the 4th, blah, blah, blah. I'm dividing that into the top, which is something x to the 5th, blah, blah, blah. What would I get if I did this division right now? X, which would mean my slope would be 1x, right? Is my slope 1? It's not 1. So that means there must have been something out front here to change that. So you do the same thing you did here. Here you went, well, it looks like it's y equals 2. Let's plug a 2 there. Here I'm going to go, what's the slope? Now, sometimes it's hard to see the slope. So I usually look until I see it hit right at another value. Hits at this value, hits at that value. Let me double check and see if it continues to do that. Down 2 over 3, down 2 over. Okay, so this is rise 2, run 3 all the way. I feel very good about 2/3. Well, the only way I would get a 2/3 out of this is if what? I was dividing a 3 into a 2 to get 2/3. That's hard to think about sometimes. The easiest way to deal with it is if the slope of that is 2/3, 2, 3. And that would take a 3x something divided into 2x something and give me 2/3. So if the horizontal is 2, throw a 2. If the slant has a slope of 2/3, throw a 2/3. Now, how do I make sure that this slanted line is actually y equals 2/3 x and it has the right y-intercept? Again, y-intercepts figure themselves out, don't they? It did here, it's going to here. So if you want to plug a 0 in everywhere for x and figure out that y-intercept, or if you want to FOIL this out and do long division, you can, but I don't care. I feel really good about where it is right now. So just like that first part was your HA, this first part is my slant asymptote. So the first part, you're only going to have an HA or an SA, right? Slant or horizontal. And it's either the value of this too. Don't use the slope of that. That would be terrible, right? Put a 0 in there. Doesn't make sense. It's either the value, y equals 2 up front if it's a horizontal, or it's the slope of that 2/3. And you could put 2/3 on the top, but it looks better with the whole number. Are you seeing this? All right, now, this is probably some of the more missed questions on the test, and I'll tell you why I do this. If I give you a problem like this and say graph it, right, and you do everything right, but you accidentally sketch the horizontal down here instead of up here, nothing makes sense and your graph becomes a disaster, and I never get to see if you graph it. If I give you something like this, I've already done the graph for you. So sometimes I want to give you just enough information to see if you can figure out the graph. The problem is people don't read. So when I give you this, read this statement. It may change from problem to problem. But what I'm saying is every asymptote is given. So that means if all of the asymptotes, so horizontal, slant, vertical, if there's an asymptote, it's there. All of the x-intercepts, what does that mean? There is no other place to cross except those three. Or in this case, these two. Are you with me? Don't try to make an extra one. All of those are given. I didn't say y-intercepts. I just said x-intercepts. Some other points have been plotted. Maybe enough to help you graph. Sketch the graph as accurately as possible, given this information. And then also assume that the x-intercepts come from odd-powered roots. If I say the x-intercepts, which is stuff in the numerator, came from odd-powered roots, what does that mean? There's no double roots or whatever that means. No what? No bounces. Did I say anything about volcanoes? No, I didn't say that the factors in the denominator weren't squared, right? I didn't say that. So be careful when you read this that you're actually putting this together. Now, sketch this thing. Now, what do I know this graph has to do? I'm only here from -9 to 9, but in reality, the graph goes from -infinity to infinity. What do we know it's doing? Following the slant. Just like I know over here, it's going to follow the horizontal. Start thinking there. Don't try to start thinking here in the middle. Start thinking here. So as I'm coming in, what are my options? I'm coming in. What are my options here? I'm going to follow it, and then as I get close to that vertical, what do I have to do? Either go up or go down. Those are my only options. But what do I have to do on this one? Also cross. So as I'm coming in, I'm probably coming in from the bottom, and then I cross this thing. Now when I cross, is it possible to turn around and come back up? Like this? Why not? Because there's no other x-intercept. Is it possible to do this and cross there? Can't cross the vertical. Well, if I can't do either of those things, what are my options at this point? Follow it down. Great. So that's my only option there. Now, coming from the other side, from -infinity, what do I know has to happen? It has to follow this slant out forever. So thinking backwards, I'm coming in on the slant. Now, what has to happen as I get closer on this slant? It's got to hit that point. Now, is it possible? Help me out. Is it possible to do this? I'm coming in on a slant. I hit this point, and I just follow the asymptote up. Why can't it do that? There's not a root there. These things, I see so many people just cross like it's like, oh, there's no bridge. Let me cross the fiercely raging river. It's the same way here. You cannot do that. And if I can't do it, what are my other options? I really have no other option than to hit this thing and to curve and head back down. So your graph looks probably more like that. And most of these sections are nice and smooth when you do them. All right. Now, is there something in the middle? Yes. Now here I have some options because I didn't say there weren't volcanoes, did I? So if I have to cross this thing, Maybe I come down from this vertical and cross, and then cross and go up. Maybe I come down and cross way and then come down. That I don't know. Of course, you can cross slants and horizontals, just can't cross verticals. So those are totally possible. But isn't this also possible? Something like that, right? But is this possible? Is it possible to hit that, bounce, and head up? No double roots. And if you're thinking, wait, if there's no double roots, how can you have a volcano there and there? That's denominator factors. Denominator factors aren't roots, right? Only the numerator's factors gave you x-intercepts or roots. So I didn't say anything about no volcanoes here, right? We were talking about x-intercept and roots. So you'd have a whole lot of options here. Like it's not a parabola, but it kind of looks like a parabola down or even a parabola up, both options. Now, what about this? It's a little trickier. Anybody got any ideas? Yeah, go ahead.
Like, if you had the equation for that, how would you tell, like, if the volcano's going up or down?
If I actually had the equation, well, I already know these parts are doing this. So if I saw that in your denominator, you had an x plus 3 and it was squared, I would go, oh, well, since I already know this is going down, this must volcano with it, right? And then if I came over here and saw x minus 2 squared, then I would go, oh, at volcano, it's going, this, I already know this side's going down, so this must also go down. All right, come over here. How are you going to start? Yeah.
The middle part is gonna come in from the top and then
You are right, but I'm going to wait on the middle because it's so much more helpful. You'll see going what you know, and you know what? It's coming in from the horizontal or the slant. So as I come in from the horizontal, we'll go from the left this time. What must be happening here? It's got to go through that point. Once I go through, is there any way to curl back up and follow the asymptote upward? Not in this case because there's not another x-intercept. So what must happen? I follow it downward. And then, of course, you don't have to draw that off the graph. But that's about what I could get out of this. What about on the right side? I'm coming in. Is there any way for me to do this? Somebody will do this in this class. Somebody, maybe more than one. And I'm just going to go, what the heck, man? Why? How do you cross that magically? There are no more x-intercepts. We've plotted all of them. Okay, so that is not an option right here. Can't do that. So what is my option? To follow it right here, and at some point start heading up to hit that hole. And then what is my only option at this point? Keep going up, right? Now, you got to have something in the middle. And you know, since there's no VA in between these points, they are going to connect, right? So if there's nothing keeping them from connecting, they're going to connect, right? So what are my options heading to the right? Only heading down. And my option to the left, if I'm crossing, only going up. Now, if that was a double root, then I could have bounced and come back down, but it said no double roots, so that's not an option. I had an uglier one than that. If I do. Okay, what about these? Now, again, if you do what I tell you, this is not difficult. What do you know? Following these things. So I know I'm coming in here. Now, as I come in, what are my options? I've got to do what? And this y-axis is not a vertical asymptote. It's just the blue, the dotted ones. So what do I know? I've got to cross. And once I cross, then I've got to cross again. And once I cross again, I have no choice but to go up. So that part wasn't bad. Now, what about the other side? Coming from there, what do I do? I gotta hit that point, which means it probably, to hit that point, I probably went a little bit higher and then hit that point, came down, but I'm not gonna quibble about that, so. So this thing probably looks something like this. And that's it. Every year I see this also. Check it out. I'll do this in green so you'll know not to, but I'll see people go, oh yeah, I also have that. What's wrong with this? Give me at least two things wrong with it.
Vertical line test.
One, now it's not a function. Guys, when you're sketching these, at the end of the day, I'm not the end of the day. As soon as you're done sketching, look at it. If it does not pass the vertical line test, you screwed up. Okay? This does not pass the vertical line test. In addition to that, what? There's no root there. I can't cross there. But I see people do things like this all the time. Just be careful so that that's not you. All right, what about this one? I'm not going to say anything. Do what? You follow along the horizontal asymptote? It's not a volcano.
Oh, I see. You can cross on the right side.
Let's think about it. You know you have to cross through this, right? Is there any way this happens? Why not? And then I'll tell you what you should have done to avoid this happens. Because this happens all the time. I see people and they go, okay. And they just wander around in space. What do I have to do as I head right? Can I ever get back to that horizontal?
No.
Not without crossing the X, and I have no more places to cross. But if you would have taken my advice, but people do that all the time, and said, hey, I'm coming in from here. What are my options? I've got to hit that point, and once I go through that point, it's pretty clear, right? I'm going to just keep going and follow that VA. So what ended up seeming tricky if I came in from the inside, if you just come in from the outside on both, you're going to be fine. All right, what about the other side? This is probably the trickiest one so far.
You can't cross the x-axis.
Starting out here. So I'm coming in on this, right? What are my options? I've got to hit the hole, and I have no choice but to go back up because there's no place to cross. I bet every year on the problem that's similar to like this on the test, at least half the people go, I didn't read, and do that. And just cross the x-axis, even though I cannot cross the x-axis. So don't do that. What really happened was you hit that hole and went, I really have no choice but to turn and head on up. Now, did it actually look like that? Maybe. My guess is it probably looked more like this. Is that you were coming down like this, and then you hit that hole and went through it, and then it just found its way back eventually. But most people, it looks kind of more like this when they do it, but I don't care. Who knows what it looks like? As long as you're following that up, following that out, and going through that hole, either one of those would be fine. Just don't go with both. You tracking? All right, so analyzing and graphing. This was your homework, I believe, in your book. Let me just make sure. Yeah, so this is actually your homework for today. If you want to, we can just start plugging through some of them if you want. Okay, so real quickly, this is not super basic, but it's a little basic. It doesn't have a lot of square junk on it, all that. But what's the first thing that pops out to you? I don't know why I always pick x plus 2, but it seems like I've done that 2 or 3 times. So right there, I'm going to get rid of that, but I'm going to pull the x value out of it. So my hole is at -2 what? -4 times -1 is 4 on the top, 2 on the bottom, 2. So -2, 2. So I'm going to go to -2, 2 and mark a hole. Then what else can I get out of this? VA, I have these in a different order this time. So my VA would be what? X equals -4. Make sure you put the X equals. Don't lose points for that. X equals -4. So I come down here and mark a VA there You know what? I can do that in a nice highlighter. All right, and then what else do I get out of this? Does it have a horizontal or a slant? Looks like it's going to be a slant, not a horizontal. So I'm going to have to FOIL that out, but that's not that hard, right? X squared, positive X, negative 2X is negative X minus 2. And I could do this with synthetic division. So I'm going to take that -4 and divide into 1, -1, -2. And look, 1, -4, -5. And the remainder part I'm disinterested in. So what does my slant end up being? Y equals what? 1x minus 5. Because remember, that's what's left, right? So 1x or x minus 5. And I go down to -5. Go down to -5, which is right here. And my slope is 1. So I'm just going to be going up 1, over 1, down 1. And I want to be pretty consistent all the way out to the end of my graph. So really, if your slope is anything, make sure that you are exiting either way correctly. What else can I get out of this? X-intercepts. So my x-intercepts or my roots are when x is 2, the y was 0, and when x is -1. Don't look down at that denominator, okay? I'm looking at the numerator. Remember, x-intercepts come from the numerator. That denominator is what gave you the VA. Right? So I can mark 2, 0 and -1, 0. Mark that point and -1, 0. Mark that point. Ooh, I like this one. And then find the y-intercept. If I plug a 0 in for x everywhere, and if I've done this correctly, I get -1/2. That's right there. Now, on this graph, I almost always get people, when they've done it completely right, they go, oh, well, I've got some points over there. Oh, look, you know these have to connect. There's no bounce because there's no squared factor, so it has to cross through. Oh, this thing must just follow that up, and this follows this up. And then they stop. They just go, oh, well, there's nothing over on that left side because there were no points. What do I know? It has to follow the slants and the horizontals. I know. And if you're like, how do you know? Remember, the only place it can't exist is there and there. Places where you're undefined. And we've already marked those, the hole in the VA. It has to be every other x value. Your domain goes for negative to positive infinity, except for -2 and -4. So I know it's coming in. So can I come in and go up? Give me 2 reasons why. There's no route to cross, and I don't have a volcano there. And if I went up like that, I would have to have a squared factor in the denominator, right? But I don't have that. So I have no choice but to go down, but where do I show up? And again, that's why I say plot at least 1 point. So if I was coming in here and plotting, I would go, well, let me figure out maybe what happens, say, at -6 or -7. So I might come up here and go, all right, let's just check -6 and see if I can figure something out. -6 in there would give me a -8 times a -5, which would be a 40 over a -2. So that would be what? A -20. And -20 is off my screen. I don't even see it, but at least I know it's somewhere down there, right? You can see it? So I would probably do this, and then at -6, wherever that -20 is, I would be down there hitting it. And again, all I need is 1 point. But I bet if I plug something like -8 in there, that gives me -10 and -7, which is +70 over a -4. That gives me what? 17-ish? Yeah, I can actually see that. So at -8, there's 16, there's 17. It's actually looks something like that. So it turns out it's a little bit lower than what I first had. But I know that something's there. Why? Because I have to follow the horizontal or the slant both ways when you're dealing with a rational function. So don't forget this half. It's so forgotten all the time. Just because somebody didn't have an x-intercept or a hole there, they think, oh, there's nothing there. No, there's always something going both directions. And why would this be wrong? Right here? Why don't I also have something like this? Give me 2 reasons.
You don't have a-
Give me 3 reasons.
Vertical line test is not for root.
I don't have I can't pass the vertical line test. I don't have a root, and also I don't have a volcano. So there's all kinds of reasons why that would be a terrible idea. Check that vertical line test when you're done. If you see it crossing twice, you made a mistake somewhere. Are y'all with me? All right. Let's look at something interesting. How about, that's not bad. Oh, we haven't done one of these. We haven't done a horizontal that's y equals 0. This is one of those. All right, so when's the bell ring? Okay, we're done. All right, guys, so just finish that up. If you were at home, finish that up. And I really don't know. We can answer any last minute questions tomorrow, and we'll be going over that. What numbers were they? 1 through 25 state stuff for that next test. All right.
Problems are gonna be on the test.
Sorry?
The state problems are gonna be on. I mean, like, other than the state.
No. I just wanted to cover this because there's so many easy questions on that test from year to year that are like, find the slant asymptote. What's the vertical asymptote? What's the so-and-so? And you're like, man, you saw 5 of them, which I'm gonna probably go over tomorrow on that Briarwood test. 5 questions we didn't get, which may not ever matter because they may never send the results. And anyway.
Test on there.
Yeah, we're gonna pick up with this the Monday after the state tournament, and then it's gonna be part of our next test.
Wait, so we're doing the
Yeah, we're
due. That's finished tomorrow and go.
You are right, it does. We'll see it. We'll play it by ear. Yeah, but you're right, I did.
Is that Caroline? Hi, Caroline. She on there?
She's on there, right, Caroline?
They
Where
like,
is she right now?
That's pretty smart, like on the bus ride back, hey, what else are you gonna do besides watch your math lesson?
No, she's not. She has.
Hello, everyone.
Hi, Karen.
She says hello. It's good to hear you.
nothing.
Thank you.
Maggie, look your eyes.
Really? Yeah.